In Part 1 of Lecture 1, we will discuss the basic layout of computer systems. An operating system exploits the hardware resources of one or more processors to provide a set of services to system users. The operating system also manages secondary memory and input-output devices on behalf of its users. Accordingly, it is important to have some understanding of the underlying computer system hardware before we begin our examination of operating systems. This lecture provides an overview of computer system hardware. In most areas, the survey is brief, as it is assumed that the student is familiar with this subject. However, several areas are covered in some detail because of their importance to topics that we will cover later in the course. At a top level, a computer consists of processor, memory, input-output or I/O components, with one or more modules of each type. These components are interconnected in some fashion to achieve the main function of the computer, which is to execute programs. Thus, there are four main structural elements: processor or processors, I/O modules, main memory, system bus. The processor controls the operation of the computer and performs its data processing functions. When there is only one processor, it is often referred to as the Central Processing Unit, or CPU. Main memory stores data and programs. This memory is typically volatile. That is, when the computer is shut down, the contents of the memory are lost. In contrast, the contents of disk memory are retained even when the computer system is shut down. Main memory is also referred to as real memory or primary memory. I/O modules move data between the computer and its external environment. The external environment consists of a variety of devices, including secondary memory devices such as disks, its communications equipment, and its terminals. The system bus provides for communication amongst its processors, main memory, and input-output modules. This figure depicts these top-level components. One of the processor's functions is to exchange data with memory. For this purpose, it typically makes use of two registers within the processor: a memory address register, which specifies the address in memory for the next read or write, and a memory buffer register, which contains the data to be written into memory or which receives the data read from memory. Similarly, an input-output address register specifies a particular input-output device. An I/O buff register is used for the exchange of data between an I/O module and the processor. A memory module consists of a set of locations defined by sequentially numbered addresses. Each location contains a bit pattern that can be interpreted as either an instruction or as data. An I/O module transfers data from external devices to the processor and memory, and vice versa. It contains internal buffers for temporarily holding data until they can be sent on.